Good afternoon. My name is Bonggeun. I'm a PhD candidate in Changwon National University. The title of my presentation is Validation of Satellite Imagery with In situ measurement considering complex urban characteristics. Contents are introduction, methodology, result and discussion, conclusion. Introduction. Recently, to mitigate urban island land surface temperature from some remote sensing data has been widely used to find a relationship with surface characteristics, surface energy fluxes, and distribution of air temperature in an area. These studies have been used. These studies are used available for urban planning and urban designing for improvement of human comfort. Therefore, for more accurate study of urban heat island, verifying accuracy of land surface temperature from some remote sensing data is very important. In previous studies, land surface temperature from some remote sensing data has been investigated by comparing with in situ measurement, but they were less clarified considering complex urban structures composed of various surface fabrics and building heights. So we compared land surface temperature between someone into sensing and in situ measurement focuses on urban complex urban sites. Process is selection of study sites and satellite images, classification of surface fabrics, remote sensing and GIS analysis, in situ measurement, construction of database in vector grid, lastly, comparison of land surface temperature between satellite imaging and in situ measurement. Study sites situated in urban area, Changwon City, Korea, South Korea, have 8 different sites considering land use types. Changwon National University campus, park, low-rise apartment, commercial area, single residential, high-rise apartment, homogeneous lawn and sidewalk brick. In selection of some remote sensing image, the S image was selected because of relatively high spatial resolution than others and collection of data at daytime and nighttime. So we collected 4S images, 2 daytime images and 2 nighttime images. In classification of surface fabric, we used land cover data, aerial photographs, and site survey. In site survey, we reduced the surface fabric from 64 to 21. In remote sensing and GIS analysis, we used shaded area because all of the areas are not sunny location at daytime. So we divided area to sunny and shaded area. For analysis, we use digital terrain model from LiDAR imaging and heat shade model function. Also, we use air temperature and surface temperature of shaded area. For geometric correction and extraction of surface temperature from thermal and SR imaging, we use PST program. In situ measurement, we collected land surface temperature data in 366 points. At daytime, between 14 and 15 o'clock, nighttime, between 1 and 2 o'clock. In situ measurement, we used Stefan Boltzmann formula to calculate emissivity of each surface fabric. We measured surface temperature and long wave radiation between 10 and 16 o'clock during 3 days, mostly clear days. In land surface temperature comparison between SEG and in-situ measurement, we constructed a grid of spatial resolution 90 meters. In in-situ measurement, we use emissivity, land surface temperature, area ratio of each surface fabric to find the mean surface temperature in each grid. After that, we compared land surface temperature in each grid with surface temperature from SEG. Results and discussion. Soil size are classified by 21 surface fabric, such as roof tile, asphalt, concrete. Highlight apartment is the highest 70 tiles. Homogeneous size are the lowest 7 tiles. In regions of shaded area, the higher building commercial area highlights apartment, the more shaded area. These pictures are land surface temperature from SEG. At daytime image, a high surface temperature was distributed mostly in artificial fabric. At nighttime image, pictures in accordance with surface fabric were not distinct than daytime image. In July 28th, in highlight apartment, simulation area happened due to influence of cloud. In region of emissivity, high emissivity was water, tile, roof tile, black, and roof tile green. Low emissivity was green roof and wood. In region of land surface temperature, at daytime, high surface temperature was wood, urethane, homogeneous sidewalk brick. Low temperature was water, green. At nighttime, high temperature was asphalt, green roof, concrete. Low temperature was wood, gravel, lawn. Surface fabric have different features of temperature because they have different emissivity and heat capacity. For example, wood is the highest temperature at daytime, but at nighttime, the lowest temperature because wood have low emissivity and heat capacity. In comparison of land surface temperature between SEG and in-situ data, RMSD was higher at the daytime than at the nighttime. ICEO of Pearson's correlation was the highest September 3rd, but lowest in July 28th due to influence of cloud. At daytime, land surface temperature measured in situ data were higher than those of SEG. High difference between SEG and in situ data was in highlight apartment, single residential area, homogeneous sidewalk with composite of denser and taller building and more artificial fabric. At nighttime, land surface temperature measured in situ data were lower than those of SEG. High difference was in commercial area, highlight apartment, and low-light apartment. Low difference was more open space open size, relatively high sky view factors, and low building density. So, three-dimensional spatial characteristics and artificial cover ratio are important law about accuracy of land surface temperature analysis. Conclusion. This study compared land surface temperature between SEG and in situ data for the application of some remote sensing data focused on site composite complex spatial characteristics. The results are land surface temperature measured in situ data at the daytime were higher than those of ST imaging, but at nighttime they were lower. High differences between ST imaging and each data were commercial area, highlight apartment, and single residential area composite dense building and artificial surface fabric. In contrast, homogeneous sidewalk free Changwon National University campus and low-rise apartment, high skyview factors and low dense building, the differences were low. In the further study, additional analysis such as relationship with surface process, considering three-dimensional characteristics will be investigated to find more accurate method. Thank you.
Thanks for your presentation. It's very informative and I think quite so good. Yeah. So I have two questions. One is how did you decide that the degree, each degree of your data is depends on the satellite or some urban geometries of this area? And the second one is, yes, we found you have a very detailed comparison for the land surface temperature and with the satellite. And what's the further application for you? I mean, because you have already realized the effect of the surface, and maybe in the future, do you have some plan for the energy consumption or other parameters in the urban area? I mean, because you can do more for the urban planner or architect, because it's kind of very important information for them. Yeah, thanks, Dr.
First question, thank you. First question is vector size, because we say as the image is pixel size, so we constructed vector size with spatial resolution micrometers. So second question is very good information location. So we after that in the future these results we use the urban planning or urban designing. So we surface fabric using surface fabric and three-dimensional characteristics. So we to mitigate urban island to plan urban design. Yes.
Yeah, I have one question. So you show us the manufacturing initiative for different kind of manufacturing type. So what instrument have you used for the initiative measurement? The instrument you used for the initiative measurement?
Initiative measurement.
Yes, what kind of instrument you used?
We measure. Sorry, one more.
Instrument, what kind of instrument is used for the instrument?
Instrument.
Sorry. We radiometer. So. We use CNR for the radiometer. So we equipment. So
The second question is, when you use the land surface temperature, you measure the land surface temperature. How do you make sure the each situ measurement is the same time and sometimes will pass. So will the length of submission continue to be longer?
Yes, or we first point and last point calculate time about time calculation of time. Sorry,
We just compared the first. I'm Coworks. My name is Bonggeun. We took us 20 minutes for exact measurement. We compared the first time measurement data and then compared with the last time measurement data. We compared the